Alright, today we are going to talk about compounds and chemical reactions. Dun dun dun! Okay, a compound is going to be any combination of two or more different elements that are combined chemically. Now it's important, alright, that we realize that it's two or more different elements that are combined chemically. You have something called a molecule. Molecules and compounds are similar, but a compound would be something like water, sodium chloride, sugar, vinegar. Alright. A molecule would be something like O2. Now a molecule is also water, salt, sugar, and vinegar, but it can also be something that is just one element, okay? So a compound, two or more different elements. A molecule can be one element that's two atoms. So just kind of know the difference between a compound here being two or more different elements that are chemically combined. Compounds are represented by a formula that uses symbols for all the elements. For example, silver, nitrogen, and oxygen. This is basically, you have one atom of silver, one of nitrogen, and then you've got 1, 2, 3 oxygen. So it would have your AgNO3 is how that would be written. And just that 3 right there tells you that there's 3 oxygen atoms. Anytime you see a subscript, which would be a number down here at the bottom, that's telling you how many there are, the total atom. Now if there's no number, that just means 1. So no number, 1. Chemical equation. You have that square right there should actually be an arrow. So there's my kind of ghetto fabulous arrows. You have reactants on one side, and things react and have a product, okay? Now, a product is like in multiplication, okay? You would multiply stuff over here, then you'd have your products and multiplication. Same thing's true here. You have reactants, okay, or things that are being combined, kind of like a multiplication problem. And then you have your product over here, which would be the answer. And one thing that you're going to notice is that this is called balanced. There's 4 hydrogen and 2 oxygen, and over here there's going to be 4 hydrogen and 2 oxygen, and so they should always be equal on this side and this side of the equation. It's called a balanced equation. And this is big. This is the law of conservation of energy. And that's really important to know, just because it's pretty basic law of science, but it's really important. Basically, it says that mass, or anything that takes up space, cannot be created or destroyed. So for example, like over here you've got 1, 2, 3, 4 different hydrogen atoms. Well, it doesn't matter what you do, you're always going to have 4 hydrogen atoms, okay? Because these right here cannot be created and they cannot be destroyed. Same thing with these oxygen atoms right here, is that neither one of these, okay, can be created or destroyed. That's just the law of conservation of mass, okay? So you have your reactants over here, and so when you come over here to the product side, you're always going to have O2. Let's start over, let's try this again. You're always going to have H4O2. Remember that atoms don't change in a chemical reaction. Okay, this is very key, that anytime there's a chemical reaction, atoms do not change. Okay, they are only rearranged. They're only rearranged. Okay, it's kind of like you've got two hydrogens plus an oxygen. There's a chemical reaction and you get H2O. Alright, you still have hydrogen and oxygen, then they're reacted chemically and you get H2O. It's just a rearrangement. Nothing's created, nothing's destroyed. It's just rearranged. Now remember, your reactants are on this side, and these things react, okay, or they multiply, if you will. And a balanced equation is going to be equal on this side and this side. So you've got 4 hydrogen, 2 oxygen, 2 oxygen. It's balanced. We're good. Now sometimes, on occasion, you'll get a number like this in front of. I don't know why this arrow right here is there, because this is called a, or it's going to be a subscript. And usually a subscript is going to be your element, and then kind of beneath it to the right you're going to have the number of atoms. But these are called coefficients. Okay, anytime there's a number in front of an element, it's going to be a coefficient. This right here is a subscript, comes after. That's a subscript that comes after. Okay, so coefficients, okay, come before elements. Subscripts go after and underneath. Now the same number of each kind of atom must be on the left side and on the right. Okay, that's kind of what makes it be balanced once again, okay? And so I've got 1, 2, 3, 4 aluminum. 1, 2, 3, 4 aluminum. Got 1, 2, 3, 4, 5, 6 oxygen. 1, 2, 3, 4, 5, 6 oxygen. If they are equal, then we're balanced and we're good. Anytime it's not equal, it's not possible.